on this new episode of Let's Talk AI. Super happy to be here today. Today we're going to talk about amazing subjects. And we are with Dipankar Mazumdar. Dipankar, how are you doing?
Hey Thomas, I'm good. How are you?
Very, very good. Super happy for this episode. Been looking forward to speaking with you. You've been
Me too.
on
Yeah.
different conventions doing speaks. Um,
Right.
so how are you doing, and how have you been doing lately?
Good. It's been like conferences season, so I've been like traveling around and speaking about the things I like. It's super fun, but also it's tiring at times. But I'm back home now, so it's exciting to just to be sitting at your desk and working on and focusing on something. Yeah.
I see, I see. So for the people who are listening who might not know you, could you do a brief description of yourself, maybe professionally and personally?
Yeah. So my name is Dipankar, and I'm currently a data engineering advocate here at Dremio. Currently, I focus on helping engineering teams build reliable and scalable data platforms using pretty much open source solutions like Apache Iceberg, Apache Arrow. We're going to talk a bit more about it today, and platforms like Dremio. I'm also very much community focused person, so I really love contributing and learning from the data community. Personally, I'm super interested in a couple of things like writing, listening to music and stuff. So I devote a considerable amount of time to going to concerts and stuff. But yeah, and I'm from Toronto, Canada.
Awesome. That's wonderful, and you mentioned a few topics, a few hints
Yeah.
of what we're going to talk about today. Um, so maybe as a first step, I think it would be very interesting before asking you a bit about your background. You have a very interesting background.
Mhm.
Um, could you share with us what are your goals today and what are you trying to achieve?
Yeah, that's a very interesting question. And to be honest, I haven't laid it out all yet. But I think, I mean, for me, one of the driving aspects for me is that I'm really passionate about like data and tech. And now that I have spent close to like a decade in this particular industry, I want to be able to give back to the community and help reduce those friction in terms of implementing technical solutions or getting started with something or the career wise. And this encompasses the work that I kind of do within my role as well. So I focus a lot on critical open source projects, like I was talking about, and that the community has been trying to implement it and adopt it. And my motive is to be able to help them out and do that with as little friction as possible, right? Because when you're getting started with something, it can be pretty daunting at first. So that's my whole goal, and be able to explain critical, conceptual, technical concepts in a more easier way would be something that I kind of constantly, focus about. Another thing is that I kind of think about bridging the gap between academia and industry, specifically for newcomers. I spent like 2 years of my time in between my career going to academics, like doing my master's in computer science, and now there is, now I'm back to the industry again. So I understand there is some kind of a bridge in between, and I want to like make sure people who are getting started in this industry, they have a pretty much kind of a smooth journey, because I personally have started with kind of like a couple of rough bumps in my career. So I hope I can make that journey a bit simpler, and that's my kind of objective right now.
Super interesting. Reducing
Yeah.
frictions, and
Yeah.
the gap between academic and industry are very two interesting topic that we'll get back.
Yep.
You mentioned you from the university, then masters. Could you make a retrospective of what you've been doing since the university, and how your career path took different steps, very very uncommon and interesting way.
Yeah, so I actually started my career as like a software engineer right after I completed my bachelor's in computer science. And then this was back in 2013 actually. So then with the, I spent considerable like 2.5 years like working as a software engineer and trying to, push code as much as I can. It was just my beginning of my career. So I really want to like write as much of code as possible. Uh, and then in 2016, I guess, that was the rise of the big data industry and with Hadoop and everything around it.
Yeah.
So I was also personally motivated by data, because I always studied a couple of subjects in my bachelor's as well. And I was like, okay, this is like looks like an interesting field. So if I have an opportunity, why not try to get into that particular field?
Right.
So I ended up doing like getting started with a big data engineering role, uh, but ultimately I switched my role to data visualization from there, because I basically saw a couple of team working on different type of visualization solution and how you can derive insights from visualizations and help your stakeholders make decisions from those visualization, right? So I think I was super driven by that. Although at that point of time I had very less knowledge around the technological aspects of it. For example, I was working with a couple of solutions like Tableau and Qlik, and then I was like doing customized visualization solution using things like D3 JavaScript, which is completely different. I didn't have the JavaScript background, but it was a fun learning experience. The learning curve was a bit tough, but I was able to execute it, so that's the best part. And from there, I worked on things like machine learning and building data platforms. And then I was like, okay, I knew a bit of visualizations, and I was getting a touch of the data industry in general, and I was getting a sense of where the data industry was moving as well. So I was like, I was applying machine learning algorithms, but I didn't have much idea on what goes around with those algorithms. How can I tune it to make it better, right? So you need a more better understanding around that. So at that point of time, it was back in 2019 when I paused my industry career for a while, and I thought I should do some research around it. So I found out a perfect master's in computer science thesis-based program here in Canada, and I ended up doing my master's in computer science there. And I focused my research area was on machine learning model explainability, and that's a area within itself. My whole goal was how can I use my background, like that's my visualization background, to basically explain different kind of ensemble models like random forest model, and that kind of gave me the edge. I was able to like publish a paper, and it was really an interesting scope for me, like coming from the industrial world and seeing how things work in academia as well. And then I thought that okay, over these years I have been always been involved with the community in some way or other, either like writing about what I'm doing or talking about it in LinkedIn and Twitter.
Hmm.
So I was like, what can I get a role that has more ability and scope to exercise all of these things, but at the same time be able to leverage my background, right, which is my research background, my ability to write things and educate people and those kind of things. So that's when I heard about the kind of the developer advocacy or the like, kind of data advocacy role. It's a pretty new role in the world of data, to be honest. But that kind of brought everything together for me, and here I am now, almost like close to 3 years in this particular role now. Yeah,
That's amazing. Very interesting how
right.
you've took the decision to evolve in one big field, but like very try, and the fact that you went for like from okay, I want to understand this deeper, so I'll do more
Yeah,
research and I'll do a master.
right.
um, and you're now writing a book. Could
I
you tell?
am.
So could you tell a bit of an introduction about the book you're writing?
Yeah, absolutely. So yeah, this is the first book I'm co-authoring actually with a couple of my colleagues here in Dremio. It's been an exciting journey, as you can imagine. I didn't have any experience writing a book, uh, so it's been a lot at times, but also it's very exciting. So I think the happiness that you get from like putting something out in such a form is
Hmm.
obviously greater than like all those effort that you put behind. So yeah, this book is about technology called Apache Iceberg that I kind of focus on. It's basically and I can talk a bit more about what Apache Iceberg later is, but in general, it's basically a new architectural paradigm called Lakehouse architecture, and basically it brings the best of a data warehouse and a data lake. And the whole idea is to be able to implement such a lakehouse architecture using a technology like Apache Iceberg. So Apache
Hmm.
Iceberg is open source; it's Apache license. It came out of Netflix data engineering team, and now it's out there. Every major kind of analytical organization, companies like Google, and even data warehousing vendors like Snowflake, and they have been trying to adopt Iceberg now. The race is kind of huge for table formats now, as you can imagine. Probably have been hearing after the Snowflake and Databricks conference as well. But I guess the momentum is huge, I would say, and everyone, because it's such an open technology and that makes your data, and I'm going to talk a bit more about open data architecture later as well. But I think the whole point is that since your data is kind of in an open data architecture, so you're not limited to one particular set of compute, whether it's your BI, whether it's your machine learning or streaming, whatever it is. And the book is going to be like the first book on Iceberg. So the whole idea is that we have been obviously like contributing a lot to Iceberg, like whether it's code. We have our open source engineering team who contributes to the code. We write a lot of blogs and all this kind of like applied articles, like how we can take advantage of Iceberg and do certain things, like whether it's CDC, whether it's large scale implementation of like solutions like streaming, like using Apache Flink and those kind of things. So the book is going to be a detailed one. It's going to be hands on as well. It's not just theoretical concepts. We're going to have code. We're going to have a GitHub repository around the book as well. So I hope this can be a great starting point for people who are experienced from that kind of background as well.
That's awesome. Um, I would like to ask you further about Apache Iceberg. So, to put a little bit of context, we see Hadoop, what we call
Yeah,
Hadoop, the first big piece, let's say, that started all
right,
of this in 2009,
right.
and it started by the Yahoo team. I don't have the leader of the team in mind, but
Yeah,
basically
yeah,
the three pieces were HDFS, Yarn, and MapReduce, correct? So
right, right.
HDFS, I recommend if you want to look into it, check
Yes,
Hadoop, and you'll have all the story, all the background. You have many documentation out there, but this is like the first piece of where we started talking about big data, and then
right.
near MapReduce, you could you rapidly saw Spark, and this is something we discussed with Andy Petrella on a previous episode. So I really recommend you to check this out. And we talked about data
Right.
observability, which is a very
Yeah.
fascinating topics, and what lays
Right.
ahead. So now that we put a little bit of context, throwing a few names for those who are listening, let us know if you're familiar with those or not. So based on this very simple, you mentioned Flink
Yeah.
streaming. So different streaming platforms, and there are a lot of pieces open source that can go into an architecture, Hadoop architecture.
Hmm.
Um, Now, could you explain us maybe how where Apache Iceberg fits into that,
Yeah.
and why it's going to play a big role in the upcoming years?
Exactly. Yeah. Okay. I gave a kind of a hint in the previous question as well, but so right to your question, like where it fits in. So with the evolution of Hadoop and like the so for me, like Hadoop file system is the data lake in the earlier world, like it's an on-premise data lake, uh,
Mm-hmm.
and that's where your all your like process files after running a MapReduce algorithm before. Now you don't have to worry about MapReduce algorithms. You can just run a Spark job and you're going to process those files and land it in that particular file system. So now with we have evolved from that kind of Hadoop era to like cloud object storage, right? Amazon S3, ADLS, Google Cloud Storage,
Yes.
all the major vendors, right? So now they are the cloud data lakes, and now the benefit of those cloud data lakes is that you don't have to really worry about scalability, right? You can
Mm-hmm.
increase as much as you want. You can provision as much as you want from these cloud vendors, and the best part is they are not even costly, they are cheaper. So that's the best part. So organizations now can they are not limited to just a warehouse where they can like where they pay money to like store data in a particular warehouse storage. So now they can infinitely scale their data as they want in these different cloud data lakes, right,
Yes.
with S3 and Hadoop and
Yes.
everything. And that's where the file formats, like I said, the different Parquet files or different JSON or CSV, whatever it is, those files they land up in those data lakes, right?
Mm-hmm.
Ultimately what you have is those files sitting in those data lakes, right?
Yes. Yes.
However, for compute engines, like for any kind of compute engine like Spark or Trino, Dremio, or whatever it is, to work on that file system, you need to be able to like do things like schema evolution. What if you change a particular schema of a particular data set, right? Will that impact something else, right? How do you change the partitioning strategies, right? You have some kind of partitioning strategy because in the big data world, you're going to partition your data lake into different partitions and buckets as well. So
Yes.
coming from the kind of like one of the first things that started with this kind of table formats was the Hive table format, if you remember, right, from the
Mm.
Facebook or the Meta team that released the Hive table format. So Hive table format basically allowed you to like take all those files and bring a schema to those files, right? Yeah, it defined a kind of a schema. And because you have a schema and a table, you can query that data using any kind of compute that you like. That's
Yeah.
what enabled Hive. But
Mm-hmm.
obviously, like Hive had certain downfalls and disadvantages as well. For example, when you are doing all those things at scale, Netflix's team realized that they were, either losing data. They when they run a compaction job, they had some kind of zombie data. That means some kind of weird data come back, or it's really difficult to even manage that kind of like a table format at scale. So Netflix's team, specifically with like cloud data lakes like S3, they realized that this was a big problem,
Mm-hmm.
because the whole problem was that Hive table format. They did it, all those files, they put them up in a directory, and that directory was actually called as a table. Whereas in now with the new table formats, we are getting rid of the directory, and all those different files that you have can directly be managed by a table format like Apache Iceberg. So you had like, if I started from the bottom, you had the data lakes, then you had the file format, and then on top of that, that's where comes your table format, which is your Apache Iceberg or any kind of table format like Delta Lake or Apache Hudi. So the
Mm.
table format basically is, in a more simpler term, you're organizing all those files, all those Parquet and Avros and CSVs in the form of a table. So now you have a schema around it, and now because that particular table format is open, and when I say open, it's accessible to any kind of engine. So if you have a streaming use case, you can bring in Flink on top of that. If you have like a distributed ETL case, you can bring Spark. For ad hoc SQL and BI, you can bring in Dremio and those kind of stuff. So really, your data is kind of in a separate tier, and it's open, and that's the best part with such an open table format.
That's
It's a
put
lot.
in a.
Yeah.
Not at all. I was about to say that's put so well together that
I'm
I
glad.
feel like
Yeah.
it is very understandable. It is the evolution basically of Hive and how to manage better
Yes,
um, data lakes,
exactly.
and how to plug easier pieces such as Spark, Flinks. I would assume
Yeah,
ML Flow and all those projects that you can use to then do whatever you need to do with your data. That's
right.
super interesting. Um, Super interesting and super
Yeah,
exciting. Also, how does that feel? How does it feel to be working on these, and how is the process of writing a book about one of the key piece
right,
of the evolution of big data?
right. Yeah, I think that's the whole perspective. So for me, like the best part that worked for me was that I came from that like early days of like Hadoop and warehousing and stuff. So I had that kind of the background, and I was understanding where the industry was kind of heading towards it. And for example, like we were like, in my past, like I have used like data warehouses and stuff, and we were always limited. Like for example, like okay, we load certain amount of data to the warehouse, and it is just stored inside the warehouse, right? I have no way, like for example, I'm doing BI and reporting on top of that. It's fine, it works great, it's structured data, so it works really good. But what if I have to deal with like more advanced use cases like machine learning or streaming, right? That's unstructured data, and data
Right.
warehouses, I mean, right now, as of now, I see a couple of data warehouses, they are going towards like incorporating a machine learning within their warehouse. But to be honest, in reality, how it works out, and what I have seen in the industry as well, is you basically, if I have to do kind of like some, your data scientists are there and they have to do their machine learning activities are on that data, you typically export a subset of the data from the warehouse to your data lake, because your data lake is an object store. It can
Mm-hmm.
really store any kind of data, right? Whether it's structured, unstructured, doesn't really matter, right?
Mm-hmm.
So how it works is basically you do kind of export and copies of the data, and you make multiple copies of the data. It's expensive, it's super expensive at scale, as you can imagine, right? And
Yes.
how are you going to even manage that data? For example, there can be problems like data drift, and it can lead to problem like model drift and stuff in the machine learning space as well. So really, the whole point is, why do you want to make so much copies when you can just be, and the reason you're doing all these copies is because the data is not open as of now, right? That's why you
Yes.
have to export all the data. So in a warehouse, you're limited to that. So I kind of saw that from the beginning, that what if this data part could be an open part, and then we could bring in any kind of compute, like you said, like ML flow, TensorFlow, whatever it is, you bring into this particular data, open data architecture, and you can leverage for it your analytical workload. So that kind of like set the background like straight for me, and then I was like, okay, I knew data warehouse, data lakes, and now with the Lakehouse, we have the best of the both world now. So really, you can have all those capabilities like a data warehouse now, but also the scalability and cost perspective that I was talking about with the data lake now.
Hmm.
So I think, even from my applied side, so there are two perspectives when writing the book. I know as of now. So we have a couple of chapters which obviously goes through like the technical components, right? The architecture of Iceberg, right? And how basically it can help data engineers or software engineers who are building that particular data platform actually
Mm-hmm. Mm-hmm.
to, for example, like debug things, right? For example, if Iceberg has a couple of technical components within itself. So how do you make sure you understand those components? You need to understand those components to debug and even go in details.
Mm-hmm.
So we are covering that part in the beginning, and that experience is what we have learned. And over the kind of couple of years, I've been focusing on Iceberg and trying to implement it myself as well. And those are the experiences that we have been gathering towards it. But also we are writing a couple of hands-on, like I said, a couple of hands-on experience and real world hands-on experience. Like for example, how can you integrate Apache Flink with Apache Iceberg, right? uh, how can you do things like machine learning with Apache Iceberg and those kind of stuff?
Mm-hmm.
Because there are certain things, for example, like Iceberg is also used as a feature store with SageMaker and AWS SageMaker and those kind of stuff. So that is super interesting. So we want to give some perspectives around the applied side as well, not just the theoretical side. And that's the kind of the experience we want to bring with the book. Yeah. So it's been a fun, from both the aspects, I would say. Yeah.
That's awesome. Um, there are different ways I would like to go about it. There are so many questions in my mind right now.
Yeah. Yeah.
Recently, we had the Databricks and Snowflake summit,
Yeah.
and we know those companies are very um, big components of for a lot of architectures nowadays.
Yes.
What is How does Apache Iceberg fits or collaborate with Databricks or Snowflake, and how does how could we see it integrated in the same system? And is that something possible? Can you share maybe a bit about that?
Yeah, for sure. So I have been obviously following because I'm part of the Iceberg community and I want to know about the ecosystem. Because for me, it's not about just the technology. Your technology can be cutting edge, but you still need the ecosystem around it for the adoption. Because you as a customer, you might have already your data in your relational database in your data warehouse, and
Yes.
it might be very stupid to say, hey, now everything is new, so you just have to migrate everything to your new environment. That's not how it works, right? so
Hmm.
so that's the whole point. So now what I've seen with like Snowflake and Databricks is that so Databricks was hard on like Delta Lake because that's their own kind of thing. And there was always this confusion between the open source Delta Lake and Databricks' like proprietary table format Delta Lake. But now it seemed to be like at parity. Now I don't know if you followed around the updates, but now they have basically released a new kind of a intermediate table format called Uniform, which basically allows you to take any kind of table format and like use the metadata, and then they can do things in their own way.
Mm.
But again, I haven't read the technical implementation part of it. There are not much documentation today. Probably we are going to see in the coming years, because from an announcement to implementation it takes a while. It's
Yeah.
mostly a POC and stuff. Yeah.
Yes.
So that might be something interesting to see where it goes. But predominantly Delta Lake and Databricks have been like in conjunction. Whereas from the data warehousing space now with Snowflake and BigQuery, they are going hard on Apache Iceberg. Uh, and the reason for that is, like I said before, you're as a customer, you have your data warehouse, like for any kind of like data warehouse, you get all your data in within the particular data warehouse system, right?
Hmm.
Whereas you can also have use cases where you want data to be in an open format, like I was talking about, right? So now what with this different data warehouses vendor, what they're telling you is that you can basically own your own data and you can
Yes.
have your own control, data lake, right?
Hmm.
And you can bring in Apache Iceberg on top of that. So now with these vendors like Snowflake, they basically allows you to even store data in an external table format like Iceberg, uh, and then you can do your analysis around it. And the whole point is that you're not going to lose on performance aspects. Like the performance is still going to be the same, whether you are storing the data within natively within Snowflake or BigQuery, or putting it in our own controlled kind of data environment like Iceberg with like your own data lake. So I think the
Hmm.
momentum is that ultimately everyone is going to adopt this kind of a table format at some point of time. It's just that now that we have seen these major kind of players, like you said, these are major players in the market, and now that we see kind of that momentum towards, like for example at Dremio, like it's a data lake house platform, and we have been adopting Iceberg right from the day, like very beginning. So that's the kind of like the push that we have. Like so, we understand like that customer data needs to be in the hand of the customer. We should not be controlling that data, right? We should give that leverage to the customer, because ultimately, your use cases can vary, right? Today you are doing BI and reporting and stuff, but maybe in the future you're going to use something like machine learning, right? So in that case, do you want to change the architecture overall? Well, no, that might be a pretty heavy migration strategy. You
Hmm.
might want to just be able to add a new engine to that already existing architecture, right? So in a way, it's much more simpler if your data is kind of open and you bring different compute towards it rather than going the other way around towards it.
Hmm. Makes total sense. Um, I like how you I like how you framed how all this technology maps together. I think
Right.
what I'm thinking right now, and what I was what maybe this is a point that I always ask myself. It feels like with since big data, we're on a constant path
Yeah.
of evolutions,
Yeah.
of improvements, of better systems, more scalable. Um, it is never um, slowing down, which is great.
Yeah.
But I have some curiosity about keeping up with the technologies, and I feel like there are different key players here. I think that we can see companies like you mentioned Netflix, for example,
Yeah.
which need to have like the top best. I mean, the data engineering team of Netflix, they're
Yeah.
very famous.
Right.
But just to name one of those companies where we have like very talented people in the tech world, and they need very optimized systems to deliver the best products. So here's my question: in the evolution, in the constant
Right.
improvements, like in the summit, in the Databricks and stuff like summit, we saw like many improvements and all of that, and then we come back to the customer, and then we could discuss about academic versus
Right.
the field. But um, how do you see customers adopting new projects in terms of what do they do? So putting in other words, I'm curious about like the how long does it takes for a project to be implemented, and who implements it first, and like what does it take for maybe like a big company that have a bit of an outdated system to
Right.
end up implementing it in their system.
Right. Right. and
Maybe
and
it's a
and
big, yeah, I mean,
yeah.
let me know if it's too
No,
um
it is a huge question. Like in general, the decision is huge, right? Obviously, like it's a very
yes.
important question. Like, and I'm glad you asked it. Like, so like I said in the beginning as well, like there is a huge difference between the cutting edge technology and the adoption on the customer side, right? Like you said,
Yes.
very rightfully, there are bigger banks, there are bigger telecom giants uh, who basically have been part of a particular system or data architecture for long now, right? And unless and until there is a major reason for like them to upgrade or migrate, it's kind of a hard decision to make, because everything is kind of stable. Your jobs are running fine, you have multiple different production application runnings based on that kind of data architecture. And now that you are talking about these new technologies, does it really make sense to for them to migrate to that immediately and stuff? So I guess overall, like for example, like I have been personally involved in a couple of cloud migration strategies in my previous roles as well.
Mm-hmm.
For example, back in my role in Otis Elevators, it's an elevator company. I was one of the data visualization side guy, leading Qlik efforts there. My whole one of the first like job task was to really take all those BI reports from running from an on-premise data warehouse to go to like a cloud environment with like AWS and Azure, and
Hmm.
really make sure those reports run on a cloud-based environment, because we were going to see a lot of customers adopting those reports, right, and dashboards and using them for their decision making. So the whole point was that we need a scalable system, and you can only scale if you're going to this kind of cloud-based solutions. But the decision to do that is kind of like a different phases and kind of different shadow migration strategies, actual migration strategies.
Mm-hmm.
So you kind of devise that. Obviously there is a huge aspect here, which is kind of the leadership push and the leadership acceptance, right? So you might, as an engineer, like I have been very opinionated in the past that okay, we should go and adopt this particular technology, and have presented towards that technology towards my management. But does it really goes to the implementation? Well, it depends. It really is there is a huge cost factor inside that, right? I'm not just talking about the monetary cost. With the open source solution like Iceberg, there is technically no monetary cost other, apart from like service, the SaaS based services around that probably.
Yeah.
But there is this total cost of ownership, right? So you have this thing, you have to, whether you want to build or buy, those kind of decisions. How much time do you have that engineering effort in your team? Even if you have the engineering effort, how long can you really go and implement that, and be able to, how soon can you really derive value from that? So these decisions are ultimately like all like comes down to this kind of different factors. Like I said, leadership is a huge aspect as well. uh, where the continuous direction is, right? Are they moving in that same kind of direction? uh, as a For example, the size of the company also matters, right? So for example, if I'm starting as a very small analytical company, or very small analytical team, I might not need all the advanced use cases like machine learning and streaming today, right?
Yes.
I can just start with BI and basic ad hoc queries and stuff, and I give an interface to my users, and they can query the data, and they can be in a data lake and data warehouse, whatever it is. Uh, so what I mean to say is that your use cases are going to increase day by day, and depending on your use case, you have to make the decision. Uh, but that vision is super important, like I said. So if you are keeping your architectures open, like I said, you can bring in different compute engine, different analytical tools towards that data, right? So you're already setting that foundation strong. So I think that is super important, and that vision is important. And I think it takes a while to really implement something from like the kind of announcement to like kind of the adoption and everything. But I think that's where I think the point of the leadership and the vision of the company and everything works towards it. I have also seen companies who have gone back. To be honest, like I was just talking to someone the other day, and I'm not going to name the company, but they are a big like company in like Canada, and they were doing a lot of like data lakehouse stuff, and now they want to go back to like data warehousing kind of stuff, because it's been a push from leadership and stuff, and they have been seeing certain challenges and stuff. So it's also the other way around. It all depends on your use cases and everything.
Hmm. Huh. Interesting. Interesting.
Yeah.
Um, okay, so I would like to ask you about data lake, data warehouse, Delta
Hmm.
Lake. But first of all, I would like to come back to something that you mentioned about Databricks, and you mentioned that the delta tables. Correct me if I say something wrong, but the
Yeah.
delta tables from Databricks are different than what we call the delta tables, like the open source delta.
Yeah.
Delta tables. So could you maybe emphasize and explain a bit what there is behind this?
Yeah, so over the years, like we have had these two different kind of like the table format is same. It's like another table format like Iceberg. It's called Delta Lake, and there was an open source part of it, then there was a Databricks managed part of it, and there were
Mm.
certain features that were available only in the Databricks managed part, and there were
Mm-hmm.
certain features were not available in open source or available in open source. So ultimately there was this confusion, and but the good thing is that now everything is what I hear is that obviously I don't work in that particular project, and I'm not sure of what's going on, but I speak with a couple of folks in database, and what I hear is that now everything is kind of open source. So now
Okay.
everything is like Delta table, like everything is the Delta lake. um, and then there are different things around it, I guess, like streaming and Delta live tables, which is like streaming part of it, and
Yes.
those kind of things. Yeah, yeah.
Exactly. And
Right.
so to put into place, I found that something super interesting with what you
Hmm.
do on a daily basis is that you have you're really taking to the people who are implementing those solutions,
Yeah,
um, as it is for maybe for the book, or for whatever reason. But you have this is so interesting to like know what's going on in a lot of companies and how they
yeah,
are reacting to the evolving field. And I feel like this is also very powerful information to
absolutely,
adapt and move faster, build faster. So
exactly.
could you, from my perspective, data lake, where you can have all kind of files all in the same place, is very interesting.
Yes,
So I was like, okay, I understand data warehouse, and then I understand how I connect my tables. I understand all of that, and I understand how. Okay, cool. But now I want to have images, and I want to do deep learning on top of it. And near my images, I want to have my customer data. So I have my data lake, and I have my
right.
processes and whatever tool I use on top of that. Okay, so um, but you've mentioned that some people went for data lakes and went back to data warehouse,
Right.
and then we have those delta tables. So I have two questions here. I'm not
Hmm.
sure how the delta tables are different from a data lake or a data warehouse, for first question. And my second
Okay.
question is, what are the factors that will make me want to have more data lake, or more data warehouse, or more of delta tables?
Right.
These are my
So
innocent questions, sorry.
yeah, absolutely. And these are the questions that I also get from the community at very frequently as well, because these are like we in the data in the and the software industry, we love jargons. Like we invent new
We do.
names and every single time. So it's good to have that kind of distinction in that. So Delta Lake is another table format like Iceberg. So technically, there are three table formats now. I don't know if you heard of Hoodie, Apache Hoodie. There is another table format that came out of Uber's engineering team.
Hmm.
Uh, there is Apache Iceberg, which came out of Netflix's engineering team, and there is Delta Lake, which came out of Databricks, right?
Hmm.
So these are the three different table formats. So you can basically adopt one of these three different table formats with the data lakes in general. With the three different table formats, like Apache Iceberg is one of them, Delta Lake is one of them, and Apache Hood is the other one. So basically you can really adopt one of these three different table formats for your lakehouse strategy. That's what so what brings those kind of like data warehousing and data lakehouse ability together is the stable format, like any one of them, to be
Hmm.
honest.
Hmm.
So a data lake, like I said, it's basically the storage, your S3 bucket, your Hadoop file system, whatever it is, that's your data lake, right?
Okay.
And data warehouses, we have already understood it. It's like a centralized repository. To me, it's more of an analytical database. That's the most common jargon that I use, like with a data warehouse. Data warehouse is a very nebulous term. So it's more of an analytical database, like OLAP DB, right? It's OLAP DB.
Okay.
So, and all these components that I talked about, right? The storage part, the file format, the table format, the compute engines, these all things, they exist in even a data warehouse and even a data lake house. The only difference is that with a data lake house, this file format, this table format is open. So that means it's accessible by all the other compute engines. Whereas with a data warehouse, this file and this table format, they already exist in that particular system. It's just that it's not open. It's unified into one single system. It's bundled up into one system, single system. So that is why you need to bring the data into the particular system and only use the compute engine from that particular analytical database. So one of the common example is, for example, if you're using, technically people also use PostgreSQL like for a data warehouse. I don't know if you hear
Yes.
about that. Yeah,
Hmm.
yeah. So it's one of the most common thing. Like back in like in the days, it used to be like the thing. Like you start with a Postgres like a database, and that kind of also gives you some kind of ability. The only difference is that all those kind of like aggregations and stuff, it's going to be very slower in a OLTP rather than our OLAP database. So the
Hmm.
whole point here is that this data warehouse have this kind of like a centralized repository. This data lake is where you have unstructured and structured any kind of data. So Lakehouse really brings like the best of the both. So you also, like with a data warehouse, you have great data management capabilities like schema evolution, partition evolution, things like compaction, right? Joining data together. uh, those now can be achievable in a data lake directly without locking your data into a particular model.
Mm-hmm.
That's the whole difference. Yeah.
Mm. That's super
I
interesting.
think you had a second question. I think
Yes,
I
it
can.
was
Yeah.
about Delta Lake and like Delta tables, Delta lakes.
Right. So yeah, like I said, like Delta Lake is one of the table format, and Delta Live table is probably one of the streaming part of it. I'm not very exactly sure about that, but ultimately that's another thing that brings like that's your low lakehouse architecture as well. So if you understand Databricks, they are a lakehouse platform as well. So their table format is predominantly Delta Lake, whereas with other organizations and other lakehouse platform, it can be like Iceberg or Hoodie and those kind of stuff.
Hmm.
Right.
So Delta Lake is a direct competitor of Apache Iceberg. Apache Iceberg,
Yeah, in a sense,
in a
like
sense.
yeah, in a sense, like if you talk about those ecosystem and those kind of people like who are building the services around it, it can be competition around that. But for people who are, for example, I can talk about big companies like I work, like you said in the beginning, like I constantly talk about, like, for example, Pinterest is a big company that uses
Hmm.
Iceberg at a larger scale, like huge scale. Like
Wow.
they have like petabytes of data, and zettabytes of data. So it's mostly like how do you implement. So Iceberg really fits works great for that kind of implementation. Apple
Hmm.
is another company that I constantly work with. Apple personally contributes a lot to the Iceberg project, open source project. Uh, so they have been implementing Iceberg at very large scale within their organization, and it really helps them with all this kind of faster analytical purposes and BI and ML and those kind of stuff. So I think that's where you see Iceberg fit really well.
Hmm. How do you feel about so in a recent episode in the Lex Friedman show, we
Right,
he received Mark Zuckerberg and he talked about the open source approach.
right.
We could discuss about threads and all of that, which is very fun.
Yeah, yeah, right,
Which
right.
is very fun to discuss. But there is this growing and more than ever part of the open source community.
Yeah,
It started. I mean, I wouldn't say the open source started in 2009 with Hadoop and all of that, but since the beginning, it have been open source and and all these companies that you mentioned like how Databricks is going to go open source, Twitter is open source,
yeah.
at Meta they're open sourcing everything. So my question is, how do you feel about the open source? How do you feel about building open source, and why is it important? And what are the some key factors of like the open source in the coming years?
Yeah, great question. And because like now in the data space, we have been seeing a huge momentum around open source solutions now. I think it's important to touch a bit about certain aspects. So, for example, like I touched a bit about the cost perspective as well. I think that's a very important factor here as well, and I'm going to cover that. But in general, I think the debate is that whether you build or you buy, right? A lot of companies now, what they're doing is, because these open source technologies, they either start in these larger tech companies like Netflix or Apple or whatever it is.
Yeah.
We understand the value because they have been implemented at such a larger scale. You can really learn from those hard experiences, right? When
Yes.
you are dealing with such a huge amount of data at such a larger scale. If you as an organization are not Apples or like Pinterest or bigger companies, you probably don't have to worry about such a large scale of data at this point of time. But it's also a good experience for you to learn from that, right? So what we as like a smaller organizations have been doing is that we are trying to, okay, Apple has implemented this and they have certain experiences, they have written blogs about it, papers about it, so we can probably implement the same in our own way, right? But we might not be such a big engineering team to really build all the solution and services around what Apple has done or Netflix has done, right? I don't have that kind of engineering resources with me. So in this case, can I look for a vendor or a SaaS solution who already kind of does this kind of services around, for example, let's say Iceberg, right? Iceberg is a common example, like in this case. So maybe instead, like for example, for your organization, if you don't have such kind of engineering resource and money, it might be better option for you to just look for a vendor who already does services around Iceberg, right? And then I can speak for my company, like Dremio is a Lakehouse platform as well, so
Mm-hmm.
it's super easy to like get started with Iceberg with like Dremio. So for example, you have your data, some of your Parquet files in your S3 bucket. You can just use Dremio to like from a like a visual interface, and you don't have to really code anything or such. You can just write a simple SQL query or even use a visual interface to create an Iceberg table. And all it does for a user is it's just a create table statement. That's it, right? And then you can do all your analyticals on top of that easily, super easily. So
Mm.
what I mean to say is that as a smaller organization or as an organization that don't have the bandwidth to like build your own things just from the like the vanilla open source,
Mm-hmm.
you can look out for these kind of like services around that, and that might be a interesting way to get started, because you understand the value of Iceberg, right? You understand the value of that open source solution, so you
Mm.
want to leverage it. It's just that maybe you don't have the scope to do that in your organization. So
Hmm.
that is super important to look at. Another important factor, cost, right? Cost, like I said, is a huge factor, right? With
Hmm.
OSS, you don't really have to pay anything. But again, there is this total cost of ownership that I mentioned, like including things like maintenance and upgrades, right? Hosting it in your in your own cloud environment or your EKS and those kind of thing, and the infrastructure around it, right? You might not have that kind of infrastructure today to support that kind of open source solution. And with a SaaS based solution, all of these things are taken care by your vendor, right? So you don't really have to worry about it. All you have to do is pay per compute or pay per licensing model. Depending on that model, you have to pay per that. So I
Hmm.
think that is another important thing. Another important like aspect which I want to mention just before I end this conversation is around uh, compatibility and ecosystem I was talking about, right? And the compatibility part also comes with customization, right? Uh, with open source, you really have access to the source code, right? And to me as an engineer, like the having access to the source code is a huge aspect of it, right? I can customize it in my own way. I can understand what that logic is doing, and I can turn it to my own company's benefit, right? I can use it in my own benefit. For example, let's say in Iceberg, let's say a particular there is a, let's say, a Spark job that's doing some kind of a compaction around, like the big small file problem in the world of big data, right? How you compact the small file into bigger files. So maybe the native source code doesn't have let's say optimized code, right? But if I
Yes.
have access to the source code, I can optimize it and make it my own, faster, or in my own way. So that's the advantage you see with open source solution, right? But with SaaS, those customization options are going to be limited. And even if you put like a feature request, like for those vendor, it might take a while to implement those feature. Whereas in open source, you just open a PR and your community can work towards implementing the PR,
Yes.
right?
Awesome. That's great, and this is also give a lot of perspective because this is something I ask a lot. If
Yeah,
I am a startup or if I am a young company,
right.
and like we're at the beginning, like where do I start building? All right, I want
Yeah,
Power BI's, or I want some data, but
right.
like do I pay a size? Like how do I cross my different data? At what point do I
Exactly.
really need to connect everything together? So those are tricky questions. But
Yeah.
worth giving a look, and SaaS at the beginning is one of the interesting answers.
Yes.
So so thanks a lot for sharing all of this. I see that
Yeah.
we're running around an hour, so
Yes.
I'll have a few last questions for you. So the first one is, do you have any tips for someone in the field today who is just getting started? There is a lot of words, we used a lot of technologies.
Yeah.
So do you have any tips for someone who is just starting in the field,
Yeah.
to do big things?
Absolutely. So if your focus is like roles like data engineering and like data platform and stuff, ultimately like uh, what I think about is like most of the time is like you hear about this shiny new tools and technologies and stuff, uh, you know but the core is ultimately the core, like for any kind of like engineering role or analytics role, is that you need to be able to understand a business problem, and you can solve it using code or low code, right? Even in today's world, like with chat gpt and everything, like we have seen like a lot of new things come up. You don't necessarily need to like spend a lot of amount of time in just probably starting something from scratch. You can use low code or no code tools as well. So the whole point is your core is understanding the business problem. You need to be able to articulate that problem and solve it using code. And I think as someone who is newly getting started, I think you keep your focus to, like, for example, you need to have understanding of SQL and, like, programming languages, like, for example, Python. I think that's good enough, like, that's good enough. But the whole point is that you need to be able to understand the logic and reasoning around it and be able to solve a problem with any kind of solution. So it doesn't really matter today iceberg is there, tomorrow there's something else come up. It doesn't really matter. The core is the foundation, and I think you have to focus on the foundation, and that's super important for starting out.
Well, thanks a lot. Thanks a lot. I have this
Absolutely.
three little fast questions that I do at the end of the episode.
Uh-huh.
But first of all, thanks a lot for coming on the show. I
Absolutely,
learned
yeah.
a lot today. I mean, in every episode, but you sharing your experiences to us, it means a lot. So thanks a lot for coming on the show
Well, it was a
and
pleasure. Yeah,
sharing
of
today.
course. Of course,
Um,
yeah.
Three little questions. Of we mentioned the tips for to grow a career. Two
Mhm.
more. How can people reach out or know more about your work, and when is the book coming out? All that kind of things.
Yeah, so I'm a social guy. I'm pretty active on LinkedIn, Twitter every single day, and now on Threads as well. So yeah, so find me out, and I kind of post around this, these new roles, these new technologies every single day on different platforms. So feel free to reach out to me for any questions that you have. The book is actually it's on an O'Reilly's early release program. So the best part about that is we can publish the chapters as we write out. So that way we can gather feedback from folks like you, and that way we can incorporate and make the book more solid and robust. So 4 chapters are already out now. I would highly encourage go and, like, give them a read and see. It's a very introductory, like, session, and then goes to more meaty part. But I think, like, that's the whole point of it. So the full book should be out somewhere in, like, next year early-ish. So I'm we'll make sure we align with the timelines and everything. But yeah, yeah, feel free to reach out to me about any technologies around data engineering, or, like, iceberg, or any kind of things. Yeah, thanks. So thank you so much for having me, Thomas. It was a pleasure. Yeah.
Awesome. And last question: do you have any message for the Let's Talk AI community? It can be
Yeah,
personal, professional, anything.
yeah. I think the whole point is that you keep learning and be curious about tech. I think the curiosity is super important. I think that's what I believe as well. And make sure you try out things with your own hands. Not just read theoretically, right? When you implement things, you understand them better. Uh, and for people who are just starting out, make sure you have milestone, and make sure you celebrate those milestone. When you achieve those, because it's very important to have those short term goals and not just long term goals. So I do that. I make sure I party after everything. I celebrate or something. Yeah,
That's awesome. Thanks a lot for these great tips, and I wish you to have a wonderful day.
absolutely. You too. Yeah.